Hello, my name is Nicholas Smith, and this is my presentation on the 5E instructional model. In this presentation, we'll talk about what the 5E instructional model is, its pieces, and the benefits of using the 5E instructional model. We'll also look at a lesson frame and where those pieces fit into that lesson frame. The 5E instructional model is just a framework for designing science curriculum and lessons. The 5E model is commonly used to build curriculum that supports inquiry-based learning. And inquiry-based learning is considered to be the best approach to teaching science curriculum. Inquiry-based learning promotes critical thinking, and therefore using this instructional model also helps teachers develop lessons that are going to promote critical thinking. The 5E instructional model has been linked to a high level of student success in many pieces of research when compared to traditional teaching methods. Students are more engaged, they have a better attitude, and they're better at resolving some of the conceptual errors that they come across. Since students are engaged in discussion and cognitive conflicts, this also prompts them to use their metacognitive skills. And most importantly, this model is practical for educators to use. It can be difficult to implement some of the inquiry-based lessons that we want to implement when we're teaching science curriculum, because we have to focus so much on specific pieces of content in order to prepare for standardized tests and just to make sure that we cover everything. And this model just provides a practical approach to implementing some of the inquiry-based learning methods that we want to implement. The 5E instructional model includes 5 stages: engage, explore, explain, elaborate, and evaluate. During the first portion, the engage phase, the students will participate in an activity that gets their attention and prompts them to recall prior information. This activity should be something that's interesting to them, something that has them puzzled, has them wondering what's happening, and is related to the content that you're going to explain later on. During the explore phase, students are going to engage in hands-on activities that provide concrete experiences that are related to the content. They might be investigating a phenomena or making predictions during this phase about something that's happening. They'll start to engage in problem solving in the engage and explore phase, but you want to make sure that the activities don't use any academic vocabulary or use very little academic vocabulary that may have been introduced previously. During the explain phase, students are going to be delivered content formally in the form of notes, graphic organizers, work walls, and that content needs to be linked to the explore and the engage phases, or really the explore phase. Before the explain phase, you don't want to give any of the things that are happening in the engage and explore phase away. And the explain phase is when you're going to explain that this is what was happening when you were manipulating those things in the previous activities. The elaborate phase just includes activities that help students solidify their understanding of the content and apply it to a concrete example. You'll be sort of resolving misunderstandings that students have during this phase, and students will just be like strengthening their understanding of the content. And then in the evaluate phase, students are going to demonstrate their knowledge through a quiz or a test. You'll see later on in our lesson, we're going to do a quiz that sort of has 3 components, and they'll receive feedback on that, which is extremely important in order for them to correct any misunderstandings. I'm going to go over the 5E lesson that I've designed for enzymes. We go over enzymes in the first unit of biology. The unit covers biomolecules and enzymes, so you'll see a little bit of biomolecules spiraled in to the lesson. This is a 4-day lesson plan, and the main TEACS is 9C, which is identify and investigate the role of enzymes. But you'll also see us go a little bit further and kind of cover the structure of enzymes. we've consistently seen that students are more successful with enzymes, STAR test questions, whenever they have an idea of the things that impact the structure and function of enzymes. I'm going to go over the lesson frame and schedule for this lesson first, and then I will switch slides and go over in more detail the 5 components of the 5E instructional model. In day 1 of our lesson, our objective is to explore the role of enzymes, and then students are going to predict an explanation for their observations in each activity. Really, they're just giving some explanation for their observations without having any background knowledge, without having gone over any content. We want to keep that a secret right now, and we'll reveal that later on when we explain to students. We have our materials listed here, and every day needs to have some kind of assessment in which we can really figure out if students have met that success criteria. So they're just going to make a little claim and evidence in an exit ticket. So the objective in day 1 is to explore the role. And really we're going to engage and explore in day 1 with 2 activities. We have a secret spit activity and a saltine cracker lab. Both of these are going to be closely related, but we're going to use the secret spit activity as more of an engage and the saltine cracker as more of an elaborate. The secret spit activity is a little more puzzling. It's kind of a crazy one, so it gets their attention, which is what we want to do with the engage. And then we list modifications and extensions down here. In day 2, we're going to discuss enzymes and the role of enzymes, and they're going to write an explanation for their observations in the saltine cracker lab. That's their success criteria, so we're linking that back over there. We have our materials, and this assessment is going to determine if they've met this success criteria right here. They're going to do a little exit ticket in which they're writing an explanation, making a claim, evidence, reasoning, writing for the observations in the saltine cracker lab after they receive the explain portion in day 2. So in day 2, students are going over, we're explaining to students what's happening. We're delivering the content formally. I'm gonna do this with a card sort that just sort of has them manipulating things and messing around a little bit before I formally deliver notes. We'll do a little bit of drill and practice because we do have to understand that content at a low level initially to mess with it some more, and then we'll do that exit ticket in which they explain what happened in day 1 during the engage and explore. During day 3, we're going to elaborate, and the objective is to explore the activity of enzymes in different conditions, and they are going to explain how each condition affects enzyme activity. We have our materials listed right here. The assessment that we're going to use to see if they were successful or not are just going to be some questions for the Pineapple Lab, which we'll go over each one of these like instructional strategies in the next slide. Students are going to do a warm-up. They're going to look at a Pineapple enzyme lab, which has them looking at how different environmental factors are going to influence the rate of enzyme activity. And then they'll answer those questions, just kind of going even further into the role of enzymes and the things that are going to influence their activity. And then in day 4, we're going to review the function of enzymes, and they're going to summarize the role of enzymes and why factors influence enzyme activity. We have our materials here. The assessment is an enzyme quiz, so we're trying to get them to just have a thorough understanding of enzymes. We'll do a little bit of a tiered review, just something real fast, and then we'll spend a lot of time working on the enzyme quiz, which is going to have 3 parts, and we'll go over that enzyme quiz in the next slide. This is a breakdown of each one of the stages of the 5E instructional model that we see in the lesson frame and schedule. For day 1, we are going to have our engage first, and for the engage activity, we're going to do a secret spit analysis. During this activity, students are going to use a cotton swab to write a secret message with saliva on a quarter sheet of paper, and then we'll show students an iodine solution, explain that it's an indicator or shows the presence of carbohydrates, and they'll dip their sheet of paper into an iodine solution. They will observe the paper turning purple and their message not turning purple, and we'll explain how carbohydrates have paper in them, but we won't really explain much else. We can have students discuss an explanation for the observation if there's time, but really in this engage portion, we're just getting their attention, having them observe something that's sort of interesting and might puzzle them a little bit. After this, during day one, we'll get to the explore portion, in which they will do the saltine cracker lab. And in this one, students are going to get a saltine cracker with no salt and break it down into 3 pieces or 4 pieces, just pieces. And we'll discuss how carbohydrates have different structures associated with their food. We've kind of already talked about that. We know that carbohydrates are all sorts of different types of food, so they're kind of aware of that. And then again, we'll show the students that crackers are carbohydrate using an iodine indicator. They will put that piece of cracker in their mouth and they'll let it sit for different amounts of time, and they'll record observations, and they will predict an explanation for their observations. They'll notice that that cracker gets sweeter over time. And we, haven't started talking about why yet. We haven't talked about what could possibly make the flavor of the cracker change over time, but they're just going to make a prediction for this. So they're sort of messing around with the same idea that they saw over here in the secrets bit analysis, sort of thinking about it, writing some kind of explanation for their observations. When we get to day 2, then we'll do an explain, and all we're going to do is do a formal, instruction activity. I like to give students card sorts and have them mess around with stuff and then put their own notes together before I give them feedback and double check their notes. Students will then complete a drill and practice activity, and we'll have them write an explanation for the observations in the saltine cracker lab. The explain portion needs to link to the explore portion, and preferably the engage portion. It needs to link to these things that they were doing before you formally introduced academic language, vocabulary, stuff like that. On day 3, we'll go over the pineapple lab for elaborate, and students are going to work in their group to observe the effect of heat and acidity on enzyme activity. They're just going to place pieces of pineapple from different experimental groups and onto prepared jello, and they're going to observe whether the enzymes from the pineapple break down the sugar in the jello or not. And they can also observe the rate at which it does this, especially this would be a good extension. And then they will write explanations for the relationship between enzyme activity and the factors in each experimental group. We're starting to, this part right here is very important. We need to address misconceptions during the elaborate phase, and they're just looking at this, the examples of this phenomena or enzymes breaking things down again in another hands-on experiment. On day 4, we'll go over an enzyme quiz. The quiz, I want to have different components so that we can assess students at different levels. The first part of the quiz, students are just going to answer questions that have them recall specific information and make simple claims. And in the second part of the quiz, students are going to observe data and then answer questions sort of using their knowledge of enzyme function. We see a lot of STAR test questions in which they're looking at data, using their understanding of enzymes to sort of work with that data and answer questions based on it. And then for part 4, or the third part of the quiz, students are going to read scenarios and then answer questions that evaluate the claims and methods of other hypothetical students or people, manipulating the same things that they were in their explore and their elaborate. In this presentation, we've gone over the 5E instructional model. We've looked at the pieces of the 5E instructional model, some of its benefits, and then we've also looked at a lesson frame that was built using that 5E instructional model. This model promotes the development of lessons that really prompt students to think critically about content and use higher order thinking skills. It is a very practical instructional model that's been shown to provide positive results with regard to student achievement. I believe it's the best instructional model for science instruction, and if you are a science teacher or any teacher, I hope that you give this model a try. Thank you.